Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at making our classes iterable. In other words, implementing a range-based for loop for our particular classes. So we've already got this ring buffer class now, which looks a lot like one of the standard template classes, but we have to iterate through it with this syntax. Now what we'd like is to be able to iterate through it with a syntax like this. So we declare a variable of the type that we've specified as a template argument when we instantiated the class here, and then we just put the actual class itself in there, and then we'd like value to be set to each of the values that this class stores in turn, one after the other. Now it turns out that you can use for if you can also iterate through the class using a more traditional looking C++98 style range-based loop. So if we can do something like this, let's say text ring, ring here, we need the type string colon iterator, or whatever your sort of iterator type is, it equals, and we need ring text string here, the actual object dot begin. We want to keep going as long as it is not equal to text ring, in this case dot end, and then we want to increment the iterator every time we go around the loop, and then we want to be able to output the thing pointed to by the iterator. It's not actually a pointer, but we've got an overloaded pointer dereference operator here. Let's just put separate those with a new line to make it a bit clearer. So this isn't going to work. None of this is going to work at the moment, but if we can make this syntax work, then this will also work. Now let's go ahead and take a look at that. I was just trying to think if I need to. I don't think I added C++11 support to this project, but it's probably going to work anyway, because I have a compiler with C++11 support built in. It's just going to give us a warning that I'm using C++11 syntax, and of course this is C++98 syntax, and it looks exactly like iterating through a vector. So if we get that to work, this should work. So what we need to implement is we need to have begin and end methods which return an iterator. So begin is going to return an iterator, whatever that is, to the start of the buffer here. Let's maybe take the last two out so we can just see 1, 2 and 3 there. So a buffer with 3 values in it. So an end here has to point off the end of the buffer, so that's something we don't ever want the iterator to refer to. That's off the end of the buffer, and we need to implement this ++ operator and the star dereference operator, and then this enhanced for loop syntax should actually work. So let's go ahead and look at our iterator class here. So we've got this nested iterator class within our ring template class, and we've already seen how to do all that. Now we're going to have to give ring these begin and end methods, so they're going to look something like this. They're going to return a iterator, and it's not going to be a reference, it's going to be a new iterator. We're going to have a method called begin, and that's going to return an iterator like that, a new iterator. And we're going to have the same thing with a method called end as well. So that's also going to return some kind of iterator. Now these, to actually set the kind of position of these iterators, we're going to have to pass some information to it. And also the iterators, even though the iterator here is a nested class, doesn't have access to the ring class's variables. It is a friend class, but it has no way of referring to those, it has no way of getting at them. So we're going to have to pass some reference to ring to the iterator, and we're also going to have to tell the iterator what position it should start at. So we want to be able to type something like this. So the begin should be an iterator to the 0th position in the class, to the beginning of it, and then we need to pass in a we need to pass in, this is going to be a reference, but we need to pass in the ring object. And we also need to, so that's in the class ring. And for end, we need to pass in, well, the position that's just off the end of the iterator is going to be the actual size of the, it's going to be the size of the buffer, because that's going to be off the end of this array. So I'm not explaining this in detail because we've already seen all this in detail. And I need to pass a reference to the ring in there as well. So let's give iterator an appropriate constructor that's going to accept those values. So we go to iterator here. We don't need this print method anymore, and we're going to implement a constructor. So the constructor has the same name as the class, of course, and it's going to take an int position. I'll call it pos, and it's going to take a ring reference. Let's call that. We could call it, I don't know, I don't really want to call it rings. That's the same name as a variable. Let's call it a ring. Okay, that'll do really. I could probably think of something better if I thought about it for a while. And we want to store those in member variables. So let's give it a private section here. Let's have an int pos. I'll call it m_pos for consistency with the convention that I've used so far in this tutorial. So member variable pos and ring m_ring, like that. So now we can say m_ring and pass in a ring. Let's maybe make it I don't know, a_ring or something, or, well, that'll do. Yeah, let's give it a capital letter for the first letter there. Let's try that. Okay, and we need to initialize the pos. So let's say m_pos is set to pos there. Well, now there's no reason that I could think of why we shouldn't make ring a reference here. Why shouldn't we just pass around a reference to our ring? We don't want to copy it. That's excessive. So let's do that. Then we can then these methods begin and end ought to work. We can return an iterator that has a reference to the ring, and it knows what position it's pointing at. Now to make use of this iterator, we're going to have to be able to increment it. We're going to have to implement ++. So to do that, we'll go back to ring here, and we need to say, so we'll make this is going to be a member function. Let's say operator. Well, it's going to return, the ++ operator should return a reference to the thing that it iterates. So let's say iterator reference operator ++. Now there's two forms of the ++ operator. There's the postfix and prefix type. The prefix type looks like this. The postfix type takes like a useless int parameter. You could actually pass a value to that operator if you called it via a method type syntax. You know, like it, if it is the iterator, it dot operator ++ brackets 7 or something, but no one uses it like that. So this parameter is useless. It's only used to differentiate between the prefix, which doesn't take this parameter, and the postfix, which does. So we don't even need to give it a name. At least with this compiler, I think any compiler as well, we can just put the type in there, and that's enough. That says this is a postfix version of this. All we need to do here is implement the pos like that, or we could do +++ pos. It doesn't matter, and then we can return the actual iterator itself to make this bit work here. We may as well have a prefix operator, because it's common to see people incrementing iterators with a ++ prefix operator as well. So that's the same, but it doesn't take this parameter there. So we've implemented that, and we also need to actually be able to get at the value that the iterator refers to. We need to implement this star dereference type operator. So let's have a go at that. So what's star going to return? Well, it's going to return type T. We want to return the thing in the actual ring at this actual position that the iterator represents. I'm going to make it return a reference. There's no point copying it. we can make it return a reference to the existing item in the ring, and that's going to be operator star. Is this going to take any parameters? No, it's not. It's purely a thing that we type in front of the iterator type. It doesn't take any parameters, and we just need to return. So we need to go into the ring here, m_ring, and we can use its get method, which we've already implemented, and pass in the position of the iterator, which is m_pos. That should probably work. We have missed one thing off, because if we look carefully here, I don't know if you can spot what I've missed if you take a look at that. Well, the answer is I've missed this, the not equals operator. We need to implement that as well to get this to work. So let's also implement that. The not equals is going to return bool, true or false. Either it is not equal or it isn't. And it's going to be operator not equal. This does take a parameter. It takes the other thing that we're going to compare it to. Actually takes two parameters, but it has the implicit first parameter of the object where it's actually declared, which is the iterator in this case. So we need iterator reference other, and that's not going to change anything, so we can make both the method and the iterator const, I should think. So let's have a go at that. I don't think we'll get any complaints if we do that. And then we can just return m_pos not equal to other dot m_pos, because that's really the definition. Two iterators are considered equal, we're going to say, if one has the same position as the other, and if they're not equal when they don't have the same position. So we just really want to apply not equals to the positions, so we can leave the hard work of doing that to the built-in not equal operator for integer here. Let's run this and see if it works. I'm never confident about C++ programs till I see them working. But yes, it does in fact work. We've got this one's coming from the sort of traditional style iteration loop, and this is coming from the C++11 style. See, since we're using C++11, we have got a warning there because I haven't enabled C++ with the right flag to my compiler. But there's no reason why we can't just use auto there as well. And in fact, we could make use of auto here, but let's just put a note. So this is C++98 style, and here we've got C++11 style. That's it for this tutorial. Well worth having a go at that. In fact, if you're familiar with this, which you will be if you've been following this tutorial and trying out the code for yourself, it's well worth trying to do that from first principles. Kind of don't look at this tutorial, but have a go at implementing that yourself. Just make sure you implement everything that this uses, and remember that for the postfix ++ operator, that actually takes one useless parameter of an int, whereas the ++ version takes no parameters. If you keep all that in mind and you apply what we've already seen in this tutorial, you should be able to implement that and get it to work. And if that works, if your compiler supports C++11, this should work as well. So see if you can implement that without referring back to this tutorial, but of course you might have to refer back if you get stuck. Okay, so until next time, happy coding.